All right, we got PSAT, October 13th, 2021. This is the calculator section. Again, check College Board if you've already done this test, see what you missed. Or if you took too long getting some right and you want to see a faster way, watch this video. Also, there'll be a link here to take the test. There'll be a gradable PDF where you can take the test for the first time and see how you do and where you need help. All right, just remember, there's always this little reference sheet kind of at the beginning. So there's some formulas there, not a lot, but a little bit of geometry stuff. Just might come into play somewhere and help you out. But most things you have to kind of memorize. So here we go. Brass is a metal alloy that consists of copper and zinc, 65% copper, 80% copper by mass. Factory uses 2,000 kilograms. Which equation represents this? So if X is the X kilograms of brass, so that's kind of one thing we need to keep track of, and Y kilograms is the low brass, all right? So high brass was 65%. So the 65% goes with the X. So we're going to do 0.65 to show 65% of the X. And then we have 80% of the Y, so 0.80 of the Y. And that comes out to be 2,000 of copper. So the correct answer here is going to be A. All right, moving on to number 2. Kind of scroll down here. So number 2 says, what is the median of the data set shown? This one's actually pretty easy because they put them in order. But remember, median is just the middle or the center of the data. Be sure that they're in order. This one is 2, 6, 12, 47, 83. So 12 is the center number. Correct answer there is B. If you ever run into an issue where there's a tie, for instance, say there's only 4 numbers, like 7, 9, 15, and 20. And you only have 4 numbers there. Well, your middle number is going to be a tie. So you have to add those up and average them. Add them up and divide by 2. In this case, it would be 12. But just be careful if there's ever an even number. Number 3, what do we have? Mississippi River has a length. So this is a conversion problem. They tell me that the length is 2,340 miles. Which value is closest in length in kilometers? So I set these up with a proportion a lot. So you give me a conversion. 1 mile is 1.61 kilometers. So that means that 2,340 miles is how many kilometers? And you can just cross multiply. So you get 1x equals, and you're just going to multiply those numbers. Some people just see that and they just know that you multiply. But if you're not sure, then you can actually just work it out in a proportion like that. I know sometimes in science class, they show you how to do conversions a little bit differently. But to me, this is the most straightforward and fastest. Correct answer there is C. Number 4, so we have function notation. And this one's a little bit tricky. I have a lot of students miss this one, just kind of misinterpretation. But so we have this rule, we have this machine that says, hey, when you drop x's into it, answers come out. So kind of picture you have this function machine, and you're dropping x's in, and what comes out are y's or f of x's, all right, the outputs. And the rule inside the machine is says, hey, anything you drop in here, multiply it by 6 and then subtract 5. So when you drop a number like, say, 1 in there, what would pop out of the bottom will be a 1. Or if you drop 2 in there, a 7 would pop out. Well, this one actually, they want to know, when does a 7 come out of there? Like, when will you get a 7 in the bottom? What x goes in to make 7 come out? So actually we're solving, when is 6x minus 5 going to equal 7? And I have to solve this. So I'm going to add 5 to both sides. And then divide both sides by 2. And I get an answer of x equals 2. Now, what they want you to do is they want you to actually solve what is f of 7. Okay, they're trying to trick with you. And they want people to put 7 in right here and do 6 times 7 is 42, take away 5, and get 37. They want you to get that answer, but that's not what the question's asking. So if you put D, you probably fell for that, so be careful. Number 5 says, which is equivalent to this big old expression. Now this is a monster, man. This is a trinomial times a binomial. So a 3 times 2, you're going to have 6 pieces. But do I really need to do all that? Let's kind of go through here and let's just look. Like right away, the very front term, this piece times this piece. When I do that, I get -4 times -2. Well, that's positive 8. And then x to the 5th times x to the 4th. Remember, you add the exponents. That's really just x to the 9th, not x to the 20th. So right away, the only one that has the proper starting term of 8x to the 9th is right here. So I'm not even going to do the rest of it because I know these guys are all screwed up and they don't work. So let's save some time. Skip all that. Number 6, population density of a certain neighborhood in Chicago is about 11,909 people per square mile. So right there, they're giving me a rate. They're giving me a rate or a ratio that I have 11,909 people for 1 square mile. All right. Well, the area of a neighborhood is 1.7 square miles. So how many people are there? So 1.75 square miles. How many people would that be? I'll just call it X. So again, I'm going to cross multiply, and it's just 1.75 times that. I can kind of ballpark that. If you call that, say, 10,000, probably looking at 12 times not quite 2. Looks like it's got to be C. Sometimes you don't even have to use a calculator. You can just kind of guesstimate it, and the answers are too far apart. All this adds up and saves you time if you can do some things in your head and do some estimation skills. Number 7 says the side length of a square is 3 times the side length of another square. The perimeter is how many times the perimeter? All right, there's a rule for this if you can remember it, but how about we just draw it? The side length of ABCD is 3 times the other one. So ABCD, this dude is the big dog, and his side length, oh, it's a square, not a rectangle. What the heck am I doing? So I got a square, and then I got a little square, and this is the EFGH, and this is the ABCD. And it says the side length of ABCD is 3 times the other one. So let's make it easy. Let's just say your side lengths are 1, and your side lengths are 3 times that. All right? So if the perimeter, how many times bigger is the perimeter? Well, this perimeter, when you add up all the sides, I get 12. This one, when I add up all the sides, I get 4. So it looks like it is exactly 3 times larger. Now be careful, because on the SAT test you take in the spring, they might just change the word perimeter to area. So be careful, because like on this one the area is 9, on this one the area is 1. So area doesn't match. Perimeter does whatever the sides do. If it was area, you got to be careful, because if you have a little area and you want to make it bigger, this one would actually be 3 squared times bigger. That gives you the big area. So when you do area, you square the multiplication factor. If you do volume, you have to cube it. It would be 27 times larger if it was a cube. Those are just some geometry rules to remember, but a lot of times I just draw a picture, man. Just work it out. All right, we have some histograms in 2 data sets. It looks like they're asking me about standard deviation. So on all the SAT tests I've ever seen, the only thing you need to understand about standard deviation is this. If you don't have an AP Stats class, you may not have really dealt with it much. But let's just say you have a bunch of data, and the data is kind of spread out all over the place. It's a really wide range of data. We're going to say that this has a larger standard deviation. Okay, so standard deviation is going to be bigger. Where if you have some data and everything is in here tight, like super tight data, you don't have much out on the edges, this is going to have a small standard deviation. So basically what you can think about is standard deviation is It's the spread of the data. How spread out is it? So when I look at this data, man, this thing ranges over the whole thing from 0 all the way to 42. So this has a bigger spread. Set B, most of the data is pretty tight. It's just in this little spot. It's not all of this. So B has a smaller standard deviation. So standard deviation is greater than B. Correct answer here would be A. More spread, bigger standard deviation. Should be a super fast, easy problem if you get one like that again. It's one of their statistics problems. The line shown above so there's an equation of this line. You could calculate it if you wanted to, but I don't think we need to. It says, if the line is shifted 6 units down, what would be the new line? Well, this line has a y-intercept of +2. Its slope looks like it goes up 2 over 1. So it has a slope of 2. So this line right here, this blue line, is y equals 2x plus 2. Well, if I shift it down 6 units, 1, 2, 3, 4, 5, 6, it's going to cross down here at -4. Same slope, just crossing at -4. Correct answer, C. All right, moving on down, number 10. Zoom back in a little bit. When we have that expression and we factor it into x plus a, x plus b, a and b are integers, aka positive, negative whole numbers, what could be a value of a? Well, let's just do this. So the name of the game when I try to factor this is I need two numbers that can multiply to make -36, and then those same two have to add to make +9. So how can you make 36? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, nope, 6 and 6, and then we're done. Well, the only way I could get a -36 by multiplying and a +9 would be to go +12, -3. I think that is the combination. So the factors would be x minus 3 times x plus 12. And it says if a and b are integers, who could be a? Well, if it's plus, it looks like it has to be 12. Okay. Now they could have put a -3 in there. If -3 would have been a choice and 12 wasn't, we would have chose -3 because, x plus a would have just been -3. It's the same thing as that one. So be careful. A lot of people might have put that one and screwed it up a little bit. All right, number 11, Cavendish's measurements of specific gravity. Don't remember that from science, but let's just see what we got going on here. This looks like a reading data problem. So Cavendish method, Earth's gravity, ratio of density Earth to water. The first bar represents from at least 4 but less than 5.0. All right, so this bar right here is from 4.8 to 5.0. The second bar, 5.0 to 5.2, and so on and so forth. How many of his measurements are at least 5.4, but less than 5.8? All right, so let's go on our chart. If we want to be at least 5.4, but less than 5.8, it looks like we're talking about both of these right here together. So there's our area. And the frequency, how many measurements? Well, we had 7 here, and we had 9 there. So it looks like we have a total of 16 with the frequency on that one. So just kind of a reading data problem, reading the bar graphs, making sure you can interpret it and what's going on. Moving on over, number 12. Looks like we have an absolute value question. So these are always a little bit interesting. You might have forgot this. It's like usually one chapter in the algebra book, or one section maybe even in an algebra book. So let me just kind of go off the grid a little bit and just explain something. A quick refresher. Absolute value of a number. So for instance, if I say, hey, what's the absolute value of -5? All it really means is take whatever inside there and make it positive. So the absolute value of +5 is also 5. So notice that if you get a certain answer out here, there's 2 cases. There's 2 ways to get that answer. So on this problem over here to the left, it says 4 times the absolute value of something equals 16. So I got to figure out, what x's could make that work. Well, first thing you want to do is isolate the absolute value bracket. Get the absolute value thing by itself. So I'm going to divide by this 4. So now I've isolated, that's all I have on the left side, is that absolute value. And now I just kind of ignore all this crap. This is just kind of like blah, blah, blah. Well, if the absolute value of blah, blah, blah is 4, either this stuff in here is 4 or this stuff in here is -4. It's one of those. So I have to solve 2 cases. I have to say, hey, when is it 3x minus 5? When does that come out to be 4? And then when does 3x minus 5 shake out to be -4? And we got to solve them both. So on this one, add 5 to both sides, and you'll get x equals 3. And then this one, you add 5 to both sides, and divide, and you get 1/3. So it looks like there's 2 answers, 1/3 and +3. So be careful on absolute value problems, because they should have 2 answers in there. All right, next one for your piano. Don't know much about pianos, but let's see what we got. The ratio, all right, so we're talking fractions here, of the fundamental frequency of a note and the fundamental frequency of the next higher note is 1 to 1.06. So 1 is for the note, and 1.06 is for the next higher note. Well, a certain note has a fundamental frequency of 370. Which of the following is closest to the fundamental frequency of the next note? I don't know. So we just proportion it out. Again, you end up just multiplying 370 times 1.06. Correct answer here is 392. All right. So this one's kind of interesting. This is a time saver question that I might be able to help you speed things up a little bit. Some people call these solve-resolve. So they say if, and then they give us an algebra equation. If that's true, and then they say, hey, what is the value of this thing over here? Well, the slow way, I'll show you the slow way first. The slow way would be to solve what's on the left. All right, not too bad. 15x equals -8. Divide both sides by 15. And then I get this. And then to find out what 5x plus 2 is, I now have to go 5x plus 2, and I got to plug that in there and solve it. Takes a lot of time. Something I want you to peek at and look at is, notice the relationship up here. And this happens a lot, like on a lot of these type of questions. If you look at this left-hand side of the equation, it's related to this piece over here. All right? If you basically just divide this piece over here by 3, you're going to get 5x plus 2. So if the answer is -2, if you just divide it by 3, I already know the answer is going to be -2/3. So they basically just shrunk. You done been shrunk. They divided that by 3, so you just divide the right side by 3. Now, if you did do it the long way and something went wrong, let me just show you how to do this. -8 over 15. Well, whenever I want to multiply a whole number times a fraction, I can just put it under 1, go straight across. So that'd be -40 over 15 plus 2. Let's tighten up that -40 over 15. 5 goes into both those numbers. So if I divide by 5, I get -8/3 plus 2. Well, 2 is basically 6/3, 6 over 3. And I get -2/3. But it would have been a heck of a lot easier to do what I did on the top. So keep an eye out for those. Moving on down. Looks like I got to shrink this one a little bit. So an exoplanet is a planet that orbits a star outside of the solar system. Scatter plot shows the relationship between X, which is the number of years since 1989, and Y, the number of discovered exoplanets. There's an exponential data, and basically we need to figure out which equation fits the chart. All right? So it's getting a little bit trickier here. So I'm kind of looking and seeing what's going on, and what's hard about this part is the graph, I can't really see where the y-intercept is because it's so close to 0. You know, so typically a lot of these things, how they start off is you have y equals, you have the starting number, all right? And then you have the growth rate. And then you have your power, which tells you how many times it does that. You know, so it's hard for me to look at the picture and know, did we start at 1.25 or did we start at 5.28? So those front numbers aren't telling me a whole lot. What I do know, one thing will eliminate half of these answers is, this thing is growing up, so it's going to have a positive exponent. All right, so I know because these two right here that have negative exponents, they're dropping. They're decaying like that, getting closer and closer to 0. Remember, negative exponents approach 0. So you guys are gone. Can't be those two. So now I just got to figure out this 1.25 and 5.28. Well, when I look at the growth rate, I don't think this thing is getting magnified by a ton, because, you know, if you look at what's going on from year to year, and, you know, I pick a number, like for instance, right in here at say like 20. And when I go over to 21, you know, it's really only growing from like 400 and something up to 500 and something. So I think that magnification power, it only growed, like if I take that 400 and I blow it up, I can't multiply that by 5.28 or I'd be up over 2,000. So I think my growth factor here, going from a dot to a dot from one year to the next year, I think it's only going up by 1.25. And if I look at another dot, like if I look at this dot here, and I don't know, say it's at 520, well, if I multiply that by 1.25, that's going to put me, you know, somewhere right up around here. That makes more sense, 1.25 times bigger than over 5 times larger. So the correct answer here is going to be C. So just kind of knowing the starting value versus the growth rate. A lot of problems will have a 2 here. So when the 2's in the second slot, that's a doubling feature. So you know that every single year it's doubling. And then the starting amount, this is always the y-intercept. So just kind of keep those in mind when you're doing the exponential problems. All right, next one, number 16. System of equations, very important concept, one of the top 5 in my book for the SAT. Usually it shows up 4 to 5 times per test, which is, you know, that's 40 to 50 points of your overall score. Can you solve a system? So this one's kind of another trick that they like to do. I could just solve it. I could find x, I could find y, and then I could add x plus y together because they want to know the value of x plus y. But sometimes you can get lucky and just add or subtract or multiply or divide a line to get the other one. I think right here, if I just subtract these two lines, check this out. 2x minus x is 1x. 3y minus 2y is 1y. And 13 take away 10 is 3. So I already know the answer to the question just by cheating it. I always, whenever I see they want more than just x or y and they want me to do something with those two numbers, I always try to add or subtract them. It's worked so many times for me. But if you don't see that trick, you'd want to use elimination here. You know, I want to look at these coefficients and I would want to try to get somebody to match up. And I want opposites. I want like a positive 2 and a negative 2. If I multiply this bottom row by negative 2, so I'm going to leave the top alone. I'm going to multiply the whole row by negative 2. And why I do that is because I want to be able to combine these two rows together, and I want something to eliminate, and having opposites makes them eliminate. So now I have negative y equals negative 7. Multiply or divide both sides by a negative 1. You'll get y equals positive 7. Hence, this answer right here that they want you to pick. So don't do that. Now plug 7 into either equation. Maybe I'll pick the bottom equation. X plus 2 times 7 equals 10. Well, that's x plus 14 equals 10. So when I subtract both sides by 14, I'll get x equals negative 4. All right? So if x is negative 4, y is positive 7, and they want to know what x plus y is, it's negative 4 plus a positive 7, which goes back to the 3. So traditional way, cheating way, it pays to learn the cheats. It really does. People think, oh no, you can't really, there's not a lot of ways to cheat the test, or shortcuts don't work. Bull crap. I do this stuff all day, every day, and it really speeds up your time, and you make a lot less mistakes. All right, the graph of a quadratic function is shown in the plane above. Which of the following could define f? So here's an important fact, and I'm kind of surprised this is on the calculator section. This would be a good no calculator question, because if you have a graphing calculator, you could very easily just plug these in and keep graphing it until you get that one right there. But it's actually much simpler than that. If you know two factors of an equation, for instance, just a separate equation, let's say that I know an equation like, and I'm just going to make one up. Let's say it's, I'll pick an easy one, x squared minus 4x minus 12. Let's say I want to graph that. Well, I could try to factor this, which would be pretty easy. If I factor it, it looks like a negative 6 and a positive 2 will give me what I need. All right, so these are called factors. Well, once you have factors, you can find the zeros or the roots by using the zero product property. You know, if something times something equals 0, either this parenthesis is 0, which occurs when x is positive 6, or this is 0 when x is negative 2. So these are what are called the zeros. So on the graph, I know that the two zeros are going to occur at positive 6 and negative 2. And then I also know like the vertex or the symmetry line is going to be right in the middle of those, which that's 8 spaces, so 4. So I know at like 2, that's going to be the midline where the vertex is going to live somewhere. All right, so back it on up. Over here, I notice both zeros are negative. So since both zeros are negative, both factors have to be positive. It's got to be. So when I look down here, the only possibility is D. So just understand that factors give you zeros and help you graph things. All right, looks like we got a word problem. The Harvey Bakery owns 5 trucks. The table is selected data about a truck, maximum fuel capacity, volume of fuel, blah, 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 blah. Average fuel consumption is the mean number of gallons per mile. So fuel consumption, gallons per mile. All right, so it says the maximum fuel capacity of a truck is P% greater than the maximum fuel capacity of truck B. What is the value of P? All right, so first off, I just want to give you a quick little refresher about how to do percent greater. So like, let's say that I have a number. Let's say that I have a number like, I don't know, and we're going to start at, I don't know, I'll pick an easy number like 20. And let's say that I want to be 14% greater. All right, 14% greater. Well, an easy way to do that is you take the number. If I multiply it by 1, it stays the same. I'm still just 20. But 14% greater, if I add the 0.14 to it, that will give me a number that's 14% greater. You know, so this would actually shake out to be 22.8. All right. If I wanted to make a number go down, I would subtract by 1. So basically, percent increase, you're either going to go 1 plus the percentage rate or 1 minus the percentage rate. So over here it says the max fuel capacity of truck A, so that's this line, is P percent greater, is how much percent greater than B. All right? So find P. I got to find how much percent greater. So if this is A and this is B, what would I do to B to get to A? You know, if I start at B, what percent greater am I going to multiply by to get A? So I just kind of do this. I just going to say, well, 12 times, 1 plus what will get me over here to 18. And I'm making this problem probably harder than what some of you that know percentages well, this would be pretty easy. So I'm just giving you like a way to solve all of them if the numbers were nasty. And then to solve this, I just divide both sides by 12. And I would get 1 plus R equals 1.5. And then to get R, I would subtract 1 from both sides. So it looks like R is 0.5, or 50% greater. All right. Now, this one was really easy because when I look at these two numbers and I'm like, well, how much bigger, how did I get from here to here? I basically just added half of myself. I started at 12 and I increased by half of myself to get to 18. So I increased by 50% of who I was. All right. If I wanted to increase by 25%, I would have added 3 to it, and we got 15. So here's that problem. Probably a long explanation for an easy problem, but oh well. All right, number 19 says, in a week, truck C, so we're talking about this one right here, truck C consumed 15 gallons of fuel. So that's how much fuel we used. How many miles did the truck travel that week? All right, well, they give us the consumption. They give us the conversion for gallons per mile. So that truck gets 0.040 gallons for every 1 mile. So if we used 15 gallons, how many miles would that be? So basically what we're doing here is we're going to cross multiply. I'm going to get 15 equals 0.040x, and I'm just going to divide both of these. Some of you may have just saw to just divide those without having to get all formal and set up a proportion, but I like to kind of break it down so that people don't just see me pulling numbers out of my rear end and wonder why I'm doing what I'm doing. So it looks like the correct answer here is 375. Correct answer is B. All right, moving right down to number 20. U.S. House of Representatives includes members from all 50 states. November 12th, it had 87 members from California, Colorado, New York, which was 20% of the total. All right, so 80, turn my marker on. So 87 is 20% of the total. How many reps on this date were not from those? So we need to find the other 80%. All right. So first of all, let's find the total. So 87 is 20% of what? A couple different ways I could do that. Some of you are familiar with the is over of percent over 100 proportion. Or you put the part over the total. So you could set it up that way. You could say, hey, 87's the 20% piece, 100 always goes there, of what total? And then you could cross multiply and have an equation. You'd have 20x equals 8,700. And then you'd divide both sides. And so I crank this out. I'm like, all right, 8,700 divided by 20, 435. So that means there's 435 total. And then you're like, okay, well, if 87 were from these three, and I need to find who's not from there, I now need to do 435 or take away the 87. So I'm just going minus 87. Boom. Looks like 348. So be sure you read the problem carefully. Another way to do this that might be a little bit faster is if 87 is 20% of the total, I could do, if I want to find the percentage of a number, I do 0.20 times the number. That would be 20% of a number is 87. And it's basically the same thing as over here. Some people just like to set it up that way. Divide both sides by 0.20. That would give you this answer. I don't think it's really much faster though. All right, number 21. So system of equations. So it's came up, this is, I think, the third time we've seen it on this test. How many solutions does this equation have? So I could try to solve it, you know, but I know it's going to kind of be a weird freak case. Just to let you know, so here are the freak cases. Normally, when two lines cross, there's three things that can happen. You have a line, you have another line, and you get one solution. That's 99% of the time, that's what happens. Sometimes you graph one line, you graph the second line, and they're parallel. So there's no solution. And then the last time, sometimes you graph the line and you graph the line, and they're on top of each other, and it's the same line. And that means that there are infinite solutions. So since this is on the graphing calculator section, if you had a graphing calculator, this would take a long time because graphing calculators, the TIs that I'm familiar with, you have to put them in slope-intercept form. So you'd have to rearrange all those in slope-intercept form, then graph them. So it's actually a lot easier the way I'm about to show you. I would try to solve this, and you're going to notice something weird happen. So first thing is, let's try to get these coefficients to be opposites. So if I multiply the top row by -4, I'm going to get -20x, positive 12y, equals -40. And on the bottom, I'm going to leave that alone. And so you see what I've achieved, what I wanted to achieve. My whole goal was I wanted opposites on the coefficients in front of x. I wanted to eliminate x. Well, when I do that, normally these eliminate. And then I do something with my y's. But if you notice here, everybody disappeared. So all the x's and y's disappeared, and I have 0 on that side. Well, when I look at the right side, here's going to be the difference between no solution and infinite solution. Since this side is also 0, I end up with a true statement. That means that these two things are the same line, and this is going to be an infinite solution problem. Correct answer is going to be D. Now, let's just pretend if the number would have been different, like let's just say that maybe this number was like 30. Well, we would have then got something like 0 equals -10, and that's a false statement. So if that happens, there would have been no solution. But the big idea to understand is if all your x's and y's disappears, you are going to have a freak case going on. All right, let's move it on down. See what we got next. All right, number 22 and 23. It's like we have one of these problems where you have multiple pieces to it, to one graph. So this is a power to weight ratio of a car. Is the car's power and horsepower divided by weight. The acceleration time is the time it takes the car to accelerate 0 to 60. Scatter plot shows the power to weight ratio for 7 cars. So those 7 dots are the cars. And then you have a line of best fit, which is right here. So here's the prediction line, or the line of best fit. And it says, for how many of those 7 cars is the acceleration time predicted by the line of best fit less than the actual? Well, it looks like there are four cars where the best fit line, the prediction, is less than the actual. The correct answer here is going to be B. Number 23, one of the 7 cars is selected at random. So this is a probability problem. The total, like out of the sample space, how many it's out of. So we know it's out of 7 because it said 7 is going to be selected at random. So that kind of wipes out A and B. what is the chance that the selected car will have an acceleration time greater than 2.5 seconds? All right, so I'm going to kind of come over here and kind of lock down a couple regions. So we want to be greater than 2.5. So right now we still have, we still have 1, 2, 3, 4, 5 people are fair game that are above the 2.5. But also they have to have a power to weight ratio greater than 2/8. So that means you have to be greater than 2/8, which are these guys. So it looks like there's only 3 left that's in that green region right here, where you're above the one and you're greater than the other. Looks like there's only 3. So 3 out of 7. Correct answer would be D. All right. Next problem. Let's zoom back in so we can read this a little bit better. Which of the following situations is best modeled by an increasing linear function? Increasing linear. So those are the key words. Remember, linear refers to constant change. You're going up by the same exact amount every year, every day. So a farmer sells 15% more produce compared to the previous market. That's not true, because when you grow by a percentage, the amount keeps getting bigger and bigger. So that's exponential. So A is out. B, a clothing store hires an additional 20 people for every new store opened. That sounds linear. Every store you're adding 20, adding 20, adding 20. So I think it's B. Let's rule the others out. A jewelry maker creates 10% more necklaces each day. So again, whenever it's percent more, that's going to be exponential growth. It's going to compound. A theater group performs for 8 fewer people. So this is linear, all right? It's constant change, but when it's 8 fewer, that would be a decreasing linear. We wanted increasing. So you're out. So the correct answer there is B. All right. Number 25. So it looks like we have a system of equations here. The graphs of 2 of the given equations intersect at the points 1, 2, and 3, 8. So that means that when I plug 1, 2 into both of those and 3, 8 into both of those for x and y, they make them true. For what value of x does the graph of that linear equation lie above the graph of the exponential? All right. So we could graph it out if we wanted to, but actually it might just be easier to plug some numbers in, because it says what value of x does the linear equation lie above. So we want the linear equation to have a greater value, to be greater than that exponential equation up above. All right. So the linear equation is 3x minus 1. The exponential equation is 2 to the x. So we want the one on the left to be bigger. So let's try the first one. We need to be between 1 and 3. Maybe I just choose 2. So if I plug 2 in here, I get 6 take away 1, which is 5. And then if I put a 2 in here, 2 squared is 4. That one seems like it works. Let's try another one just to rule some numbers out. Pick a number between 2 and 8. Maybe we'll try 3. So 3 times 3 minus 1, that's 9 minus 1, that's 8. And over here, if I do 2 to the 3rd power, well, that's 8. And the linear is not greater than. They would be equal. So I know it can't be here. Smaller than 1 and greater than 3, that's not even possible. I can't be smaller than 1 and bigger than 3 at the same time. And less than 2, but bigger than 8, that's not going to work either. So correct answer here is A. I also think if you would graph these, I would kind of be done and move on, but if you wanted to graph these, you kind of come down here and, I don't know, maybe we'll go 1, 2, 3, 1, 2, 3. And I could do the 3x minus 1, so it's going to have a y-intercept at -1. So I'm graphing this line right here. Intercept at -1, it's going to go up 3, right 1. And then up 3, right 1, which will be somewhere up in here somewhere. So we have that line going on. It's kind of squiggly, but bear with me. And then the next one, y equals 2 to the x power. I'll do this in red. If I was going to graph that, you might want to just make a little quick table. If x is 0, then anything to the 0 power is 1. So I know 0, 1 is in the mix. If I put 1 in for x, 2 to the first power is 2. So over 1, up 2. Well, right now they hit the exact same spot. And then 3, it said 3/8 is going to be the same. So if I go over 3 up 8, that's going to be way off the grid. But I think what's going to happen is this thing is going to kind of come like that. And it's actually going to come out here. And, at 2, it's going to be 4. So over 2, up 4. So that would be right around in here. And then it's going to kind of go way up. Well, you can see that the blue line is actually above right from here, from 1, and then they meet again at 3/8, it said. So this range between 1 and 3 is where it's above the line. So you could have did algebra or graphing, whatever you're stronger at. All right, let's go down to 26. A lot of times algebra is quicker if you know the algebra, but sometimes you got to graph it out. For positive values of j and k, j is 25% of k. I'm going to write an equation there. J is 25% of k. All right? Which expression represents k in terms of j? So that whenever you see this, k in terms of j, that just means solve for k. They do this a lot. They want you to solve for a different variable. So all I'm going to do is I'm going to divide both sides by 0.25. And I get k equals j over 0.25. And unfortunately, I don't see the answer there. So it looks like there's no decimals. So maybe I'm going to multiply the top and the bottom by 100. All right. So that would give me 100j over 25. And the correct answer here would be C. So it's kind of a weird way that they ask it. But 27, Imani pours iced tea into an empty dispenser at a rate. So this is a rate problem. So we need to set this rate up. X liters. So X liters for every Y minutes. All right. It might be 10 liters every 2 minutes, or who knows. X liters over Y minutes. Which expression represents the number of minutes it would take Imani to fill the dispenser with 11 liters? So I can set this up a proportion. If it's X liters to Y minutes, it would be 11 liters to, and normally I'd put a letter, but we already have letters, so I'm just going to put kind of a question mark. So we're trying to figure out what that question mark there would be. So let's kind of multiply both sides. So we get 11y equals question mark times x. And we want to know what question mark is. We want to know the number of minutes it would take. This was our minutes. So I divide both sides by that x, divide by the x, and looks like 11y over x. Correct answer there would be D. Something else you might want to do is you may just want to pick some numbers. You might want to be like, hey, how about, 1 liter every 2 minutes? And then you say, okay, if I can do 1 liter in 2 minutes, then I would do 11 liters in how many minutes? And then you can kind of manipulate those and working them around. So this would be, 22 minutes. Well, how did you find the 22? Basically, you cross-multiplied those two. So that gives you your 11 times y. And then you're going to divide by what's across from the x. So you could do it with numbers as well. All right, what do we have here? A spinner. So this is a table. Looks like a probability, a two-way table. They really like these. So know that two-way tables, they go across and then they go down. So if you kind of focus on this row, this is the even row. So it looks like there's 10 blue, 6 green that are even. Then you have an odd row. So you notice that 5 plus 10 equals 15. So you can go that way. Then notice you can also come down. So these are just all the blues, you know, and these right here would be all the greens. I guess I should have color coded the first one. And then the key thing to understand is this total 31 is everybody. All right, that's the whole thing. So often that number comes into play. Let's just see. So we had a spinner, and it was blue and green, and they had evens and odds. So if the spinner landed in a section with an odd number, so we landed with an odd number, we know that. So if I set up a probability, and I know that we ended with an odd number, we landed in an odd number, so we're talking about out of this group right here. So out of those 15, what is the chance that the spinner landed in the blue section? Well, out of the odds, there were only 5 blues out of the 15 odds. It says express your answer as a decimal or a fraction, not as a percent. So I'd reduce this down to 1/3. You also could do 0.33 or 0.33, but I like to do the 1/3. Let's keep on going. So number 29. So it looks like we have some sort of a dot plot on this one. So this would be in the statistics area. So the dot plot above shows the number of House reps in states with fewer than 10 reps for 16 states and 21 Western states. So we have 16 states over here. We have 21 dots over there. What is the median number of House of Representatives for all 37 states in the dot plots? All right. So, you know, if you wanted to write this out, this would be kind of long if you wanted to write all this stuff out. But if we just tallied it up and we put all the lowest numbers first and the biggest numbers second, if you look at the ones, we have 1 from the Eastern, and then 1, 5 of those. So 7 total. So we have 7 ones, all right? 7 states with 1 representative. Then when you go to the twos, there are, you know, these 3, and then there are these 2. So we have 5 twos. 2, 2, 2, 2, 2. And kind of zooming forward a little bit, if I know there's 37 states, the median is the middle number. So I'm like, all right, what's the exact middle of 37? And basically, if you take the next lower even number, so you do 36, and you chop it in half, well, that would be 18. And then we got to add 1 to that. All right? So it's going to be 19. The 19th number will be exactly in the middle. So I'm trying to figure out, you know, where is the 19th number going to show up? And instead of writing all these numbers out, you know, like right now we've already got 7 plus 5. You know, right now we're up to 12. But we need to get to 19. Well, if I look at the 3s, you know, I have 1, 2, 3 more 3s. So that's going to get me up to 15. And now the 4s, I have 1, 2, 3, 4, 5, 6. 6 4s is going to do it. Because now when I do 6 4s, 16, 17, 18, 19, 20, and 21, right there, what were we at? 15, 16, 17, 18. That's going to be the middle number. All right. Now, once you get good at this, you don't have to draw out all those 1s and 2s and whatever. When I usually do the problem, so the correct answer is 4 to this one. But when I usually do the problem, what I do is I find out the total number, I find the middle, you know, cut it in half and then add to get up to the next one. So it'd be the 19th number. And then I just kind of go through here and I'm like, all right, 2 and 5, that's 7. And then 3 and 2, that's plus 5 more. And then there's plus 3 more. 1 and 5, there's plus 6 more. And that right there, I'm at 12 plus 9. I'm already up to 21. So it occurred during this batch of 6s. So it occurred in the 4s. So you can kind of do it without writing all the numbers out. All right, that's 29. So we got to go up and pick up 30. So number 30, the equation of lines shown above can be written as ax plus by equals 12. So ax plus by equals 12. A couple different ways to do this. I notice a couple numbers on the line. So let me first, it's kind of confusing to see where the axes are, but here's the x-axis, here's the y-axis, and we have some intercepts, which are going to be very useful. So we have a couple intercepts. We have some points that work. So in this table, in my little xy table, I know that when x is 0, y is 6. And I know that when x is 4, y is 0. So right there, I can kind of plug those numbers in, and I can get some information from that. So 0, 6. So when x is 0, that's going to wipe out this term right here. That's going to be gone. So when you plug x equals 0 and it disappears. So b times what equals 12, and we know that y is 6. So I'm going to plug 6 in for y. You know, so what times 6 equals 12? Well, it looks like b has to equal 2. And then if I use the other point, if I kind of come back up here, and I use this other point, and I substitute, and I'm like, well, I'm going to put 4 in for x. So a times 4. And then that's going to be plus b times 0, which is basically going to disappear. B times 0 is gone. So what times 4 is 12? It looks like a equals 3. And what do we want? What is the value of a? So correct answer is going to be 3. So kind of an awkward problem. Not something that you would typically see. There's other ways to do that, but I think that's probably the most straightforward way. And number 31, the function h of x equals that decimal. I see it's in vertex form. So right away, before we get too far into this problem, I just want to know, like, before I read anything, what I'm noticing is I have a negative number in front. So I know this is going to be a parabola concave down. This number right here being such a small number means it's going to be very, very long and fat. And then I'm going to get a vertex out of this thing. The vertex is going to be the opposite of what's in here. That's the x value. We had one of these earlier on the no calculator, I believe. And then this is going to be the y value. All right? So I have the x and the y value of the vertex, which I know is going to occur right here at the max, at the highest point. So let's see what we got. Models horsepower and wheels of a vehicle with a poorly maintained diesel engine. So x is the engine speed. All right? So this right here, x is the engine speed in revolutions per minute, where x is somewhere between 1,600 and 2,100. What is the engine speed at the vehicle's horsepower is at its greatest? Well, this is horsepower, all right? Y is horsepower, or h of x, whatever you want to call it. So horsepower is its greatest at 310 at the vertex. And the revolutions we need to get this max horsepower is right here at 1905. So there really wasn't a lot to do to this problem as long as you understood what vertex form was and that you can find the max or the min when it's written in vertex form. It just makes life really easy. All right, hopefully this helps you out. And if you want to check out any other videos, just go to the channel and try some other tests. See you.